Hi everyone, we're back with another math paper today. This is 9709, paper 52, May June 2023. The time is 1 hour 15 minutes. Before we begin, let's take a look at the threshold. So for this paper, paper 52, here we go, this one over here. I plan to do the others as well soon, as soon as I can. So yeah, A was at 38, B was at 31, C was at 25, D was at 18, and E was at 12. Interesting. So this is it. So let's write that down over here. So the full marks is 50, and out of that, A was at 38, B was at 31, C was at 25, D was at 18, and E was at 12. So you can see that there's a gap of 6 to 7 marks in between. So A star would have been at something like, maybe 44 to 45. That's the mark for A star that you'd require. Also, before we begin, I want to talk about my Patreon channel that I launched recently. If you like the content, please do subscribe to the channel, like the videos, it helps with the algorithm a lot. Also, consider supporting me on Patreon. It's patreon.com/CIEpapersolved. There are 3 tiers. The first tier is just for support. The second tier is for notes and paper solving requests. And yeah, you get access to ad-free videos as well as my chapter-wise notes for physics and chemistry, as well as some solved papers for physics, chemistry, math, and biology. For science, it's paper 1, 2, 4, and 5, and for math, it's S1, P1, P3, and M1. For this tier, it's just access to the recent years, recent 4 or 5 years, and for this year, you get access to my complete library from 2002 to 2023 onwards, as well as you get access to one-on-one video meetings with me where we can discuss your problems. This is the ultimate learning experience. It's the $15 tier. So yeah, please do consider supporting me on Patreon if you do like the content. So without further ado, let's begin. Starting with question number 1. Start. The random variable x takes the values minus 2, 2, and 3. It is given that px is equal to x equals to k x squared minus 1, where k is constant. Drop the probability distribution for x, giving the probabilities as numerical fractions. Alright. So the random variable x takes the values minus 2 plus 2 and 3. So the table should be like this: x probability of taking x. So what are the values of x? It is minus 2, 2, and 3. Okay, now we need to find out the probabilities. Okay, so hear me out. Px is equal to minus 2 will be k into minus 2 whole square minus 1, which is k into 4 minus 1, or 3k. Next, for px is equal to plus 2, it's going to be k into 2 square minus 1, which is 4 minus 1, also 3k. And for the last one, it is px is equal to 3, which is k times 3 square minus 1, which is k, 9 minus 1, which is 8k. Now we found out that this is 3k, this is 3k, and this is 8k. We know that if we add all of them up, the summation of the probabilities will be equal to 1. So what can we write? We can write that 3k plus 3k plus 8k is equal to 1, or 6 plus 8, 14k is equal to 1, or k is equal to 1 by 14. This is my working. Now if I just put that in here, 3 into 1 by 14 is 3 by 14, this is also 3 by 14, and this is 8 by 14, which you could round off as 4 by 7. That's also fine. So that's our final answer. Moving on to part 2, find expectation and variance. So we know that the formula for expectation is the probability multiplied by the value itself. So what should it be? It should be minus 2 times 3 by 14 plus 2 times 3 by 14 plus 3 times 8 by 14. Okay, so minus 2 into 3 by 14 plus 6 by 14 plus 24 by 14. It's 12 by 7. Next, moving on. It's best if you show the working actually. Like, take another step, please. It's best if we show the working. This is equal to minus 6 by 14 plus 6 by 14 plus 24 by 14, which is 12 by 7. Yeah. And for variance, you know the formula. Variance of x is equal to, basically, it's the summation of the squares of x times f, right? So minus 2 whole square times 3 by 14. So that's how you write it. Minus 2 whole square times 3 by 14 plus 2 square times 3 by 14 plus 3 square times 8 by 14. So this whole thing, right? This whole thing minus expectation whole square. So if we put it in, what is it? Actually 4 times 3 by 14 plus 4 times 3 by 14 plus 9 times 8 by 14 minus 12 by 7 whole square. Now what? This is basically equal to 12 by 14 plus 12 by 14 plus 72 by 14 minus 12 by 7 whole square. So after subtraction, 12 by 14 into 2 plus 72 by 14 minus 12 by 7 whole square. We get 192 by 49. Or you could write it as 3.92 to 3SF, since it's an irrational number. Is that fine? All good. Let's move on to question number 2. A sports event is taking place for 4 days, beginning on Sunday. The probability that it will rain on Sunday is 0.4. On any subsequent day, the probability that it will rain is 0.7, and if it rained on the previous day, it is 0.2. Sorry, if it rained in the previous day, it is 0.7, and if it did not rain on the previous day, then it is 0.2. Find the probability that it does not rain on any of the 4 days. Okay, let's see. So we have Sunday, Monday, Tuesday, and Wednesday. So let's do this. So the first step is, it might rain and it might not rain. Rain, and yeah. Just want to check something. Rainy day and dry, right? Does not rain. Rain does not rain. D4 does not rain. So what's the probability for the first one? It is 0.4, so this should be 0.6. Now, if we go further, on Monday, rain does not rain. So on any subsequent day, that's the wording. So for Monday, the probability that it will rain is 0.7 if it rained on the previous day. So this is equal to 0.7, while this is equal to 0.3. Kind of like that. On the other hand, if you go here, rain does not rain. Here, if it did not rain on the previous day, the probability of raining The probability that it will rain is actually 0.2. So this is 0.2 while this is 0.8. Now we don't need to draw the whole thing because it will get rather complicated. We just need to find the probability that it does not rain on any of the 4 days of the event. So we can just go further. I'll just follow the does not rain journey. Does not rain, does not rain. So again, rain, does not rain. This is gonna be, if it doesn't rain, the probability of raining is 0.2 according to the question, and not raining is 0.8. And finally, the last step, if we go again, rain, does not rain, rain is 0.2, does not rain is 0.8. So as you can see, I didn't draw the whole tree diagram because it would get rather complicated. This would have 2 roots, this would have 2 roots, this would have 2 roots, and then each of these would have 2 more roots. So yeah, I decided not to draw the whole thing. We might need it later on though. Find the probability that it does not rain on any of the 4 days. So basically, probability of no rain on 4 days, or it's basically P D D D D, that is basically equal to 0.6 times 0.8 times 0.8 times 0.8, which is 0.8 whole cube. Alright, this gives you a value of 0.3072, or you can keep the fraction 192 by 625. Okay, this is an exact answer, by the way, which is why we did not round it off. 0.3072, I mean. Anyway, find the probability that the first day on which it rains during the event is Tuesday. Okay, so we need the first day of rain on Tuesday. So what does that mean? Does not rain on Sunday, does not rain on Monday. Follow me, follow me. Wait, let me use this. Does not rain on Sunday, does not rain on Monday, and rains the first time on Tuesday. Okay, so P, probability of does not rain, and then rains. So this is essentially does not rain 0.6, does not rain 0.8, and then rains. That should be 0.2. Okay, so let's do the calculation. 0.6 into 0.8 into 0.2, 0.096. Fine. Or you could go for 12 by 125. Same answer. Next, find the probability that it rains on exactly one of the 4 days of the event. Okay, so this is a rather complicated one. P rains on one day. This is basically equal to P. Suppose rain, does not rain, does not rain, does not rain. Then P does not rain, rains, does not rain, does not rain. Plus P does not rain, does not rain, rains, does not rain. And finally, probability that it does not rain on Monday, does not rain on Sunday, does not rain on Monday, does not rain on Tuesday, and then rains on Wednesday at last. So we need to find these 4. And yeah, let's start doing it then, step by step. All right, so the first one, P R D D D, does rains, then does not rain subsequently for the 3 days. Let's find this out. So rains on the first day, does not rain on the second day, and then rain, does not rain. So if it does not rain on the previous day, the probability of raining on the next day is 0.2, 0.2, 0.8, and then it won't rain again on Wednesday, which is rain and does not rain. Since it did not rain there, it's 0.2 and 0.8 again. Okay, so that is one. Another one. So this is my first one, right? Which is, let's follow it. Rains on Sunday, does not rain on Monday, does not rain on Tuesday, does not rain on Wednesday. It's 0.4 times 0.3 times 0.8 square. So 0.4 times 0.3 times 0.8 square, or times 0.8 times 0.8, which is 0.0768. Okay. Now let's go to the next one. Does not rain, rains, does not rain, does not rain. Okay. So does not rain, rains, does not rain, does not rain. Okay. So I think I needed more space over here. I might have messed up a bit. It's fine though. Trying to fix this. Okay. So does not rain, rains. Oh, at the end I have to draw all of them, it seems. Let's see though. Okay, so does not rain, rains. Then here you go, rains, does not rain. So for this, since it rained on the previous day, the probability of raining will be 0.7 over here and 0.3 over here. And then on the final day, it won't rain again. So rains, does not rain. Here the probability is 0.2 and 0.8, as it did not rain the previous day. So if you follow the track, what is it? Does not rain, rains, does not rain, does not rain. So that's 0.6 times 0.2 times 0.3 times 0.8. What was it? Yes, 0.6, 0.2, 0.3, 0.8. Right? 0.6, 0.2, 0.3, 0.8. This is a rather time consuming sum. Next one, we have P does not rain, does not rain, rains, does not rain. Does not rain, does not rain, rains, does not rain. I think I need more space here, clearly. It's not fitting. Wait, let me just transfer this elsewhere. Then let me just do it again. Wait. Let me just fix things. It should be better now. Sorry for wasting some time. I'm just drawing all the roots first, okay? So this has two roots. It does not rains and does not rain. This also has two roots. It is rains and does not rain. The next one has four roots in total. It is rains and does not rain. Also rains and does not rain. Rains and does not rain. Rains and does not rain. And finally the last one, RD, 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 RD. Finally, this one has 1, 2, rain does not rain. 1, 2, rain does not rain. 1, 2. Oh God. Okay. Um. So this is the whole diagram. So as you know, on the first day it's different, and on any subsequent day, if it rains the previous day, the chance of raining is 0.7, right? So this should be 0.7 and this should be 0.3, and if it does not rain, it's going to be 0.2 and 0.8. So it rains on the previous day, it is going to be 0.7, it's going to be 0.7 there as well, and yeah, it's going to be 0.3 over here. And on the other hand, if it does not rain, what do we get? It's going to be 0.2 for raining and 0.8 for not raining, 0.2 for raining again, and 0.8 for not raining, because it did not rain the previous day according to the question. Now let's fill up the other ones. If it did not rain on the previous day, it's going to be 0.2, 0.8. If it rained on the previous day, 0.7, 0.3. Okay, next. If it did not rain, it's 0.2, 0.8. If it rained, it is 0.7, 0.3. If it did not rain, 0.2, 0.8. If it rained, 0.7, 0.3. If it did not rain, 0.2, 0.8. And similarly, if it rained, it's 0.7 and 0.3. This is your whole diagram. Now, what was I looking for? I already did this one, by the way. I did rained, did not rain, did not rain, did not rain. I'm done with this. Then I also did this. Did not rain, rained, did not rain, did not rain. Now I'm gonna go for the next one. D D R D. D did not rain, rained, and then did not rain again. D D R D. Okay, so 0.6, 0.8, 0.2, 0.3. 6823, 6823. Okay, 6, 8, 2, 3. Good. This is also 0.0288. So we're actually seeing a trend here. For the final one is PDDDR. Let's check this one out. Where is it? Wait. It is DDDR 6882. 6882. Isn't it similar to another one? 0.6 into 0.8 into 0.8 into 0.2. 0.0768. So as you can see, these two are, oh, they have the same answers, although the working was different. Okay, so there was no shortcut to this. You actually had to go through all the hard processes. So P rains on one day, at least one day. What are we getting? We just have to add these up. 0.0768 times 2 plus 0.0288 plus 0.0288. This gives me an answer of 0.2112. I added them up. 0.2112 or 132 by 625 if you prefer fractions. Okay, that's up to you guys. Okay, let's move on to the next one. Question number 3. I actually have 3 done. I did it before. Let's do it again. No problem. So the following back-to-back stimulative diagram represents the monthly salaries in dollars of 27 employees at each of 2 companies A and B. So find the median and interquartile range of the monthly salaries of employees in company A. Fine. So firstly, for median, we need to find out the total number of employees, 27. So for odd numbers, the formula for median is n plus 1 by 2, that value, 27 plus 1 by 2, which is the 14th value. So let's count the 14th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This over here is my 14th value. Okay, so this value over here, this one, what does it mean? This means 2710 for company A, for example. So yeah, it is 2710 for company A. That's the median. That's Q2. Now let's find out the interquartile range, which is Q3 minus Q1. So we know that we can't split 27 equally. So what can I do? I can isolate the 14th value Out of the 27 values, I'm isolating the 14th value. So on the left hand side, I have 13 values. On the right hand side, I also have 13 values more. So this is my Q2, right? So Q1 will be the median of the first 13 values, and Q3 will be the median of the next 13 values. So what is the median of 13 values? 13 plus 1 by 2, which is 14 by 2, or the 7th value. So let's start 1, 2, 3, 4, 5, 6, 7, this one over here, and then 1, 2, 3, 4, 5, 6, 7, this one over here. So that is 2610, that is Q1. That is $2610, and for Q3 it is 2840. That is your Q3, 2840. Now if you subtract them, 2840 minus 2610 is $230. That is your answer. Okay. Now we have a box and whisker plot in the next part. So remember, the basic gist is, for box and whisker plots, we need 5 values. Okay. We need the least value, we need Q1, we need Q2, we need Q3, and the highest value. Okay. So let's begin. The data for company B is given. The quartiles Q1, Q2, and Q3. Also, we can find out the least and highest value. They are 2540 and 3090 respectively. 2540, right? 2540. So least value, highest value. So we are asked to plot on a single diagram the box and whisker plots for both of them. So I start with my scaling. I see that 2500 is my least value, while 3090 is my last one. So my last one has to be 3100 at least. My last value has to be 3100, and my starting has to be 2500 at least. So I saw that I could start from 2400 and it would fit. Okay. So what's the next step? Let me show you how I plot B. So my least values are gonna be whiskers, while my highest values are gonna be boxes. So 2600 and 2690, right? So where is that? We can draw this higher. It's gonna be better for us for comparison, right? So yeah, we can give two boxes for. We can give two boxes. It's up to you guys, honestly, what you guys want to do. Like two big boxes, right? So for example, how many are there in total? 1, 2, 3, 4, 5, 6, 7, 8, right? Let me show you. 1, 2, 3, 4, 5, 6, 7, 8. So yeah, we can start with this. So 2600, which lies over here, like this. And then where is Q2? 2690, 2780. 2690. Each box is 10 over here. So 2690 and 2780. 8 boxes away. And where do they end? 3090 and 2540. 2540. 1, 2, 3, 4. You can give the same length or lower. It's honestly up to you guys. And 3090 respectively, which looks like an outlier, honestly. 3090. Yeah, there you go. This is, we need to label it, of course. This is company B. Okay, you can label it on the diagram or outside. That's fine. Company B. And you need to label the axis as well. What's the labeling of the axis? It is dollars. Okay. Now for company A, what was the value? 2610, 2710, 2840. And the least and highest value are 2500 and 3010 respectively. Let's begin. So 2500 and 3010. So yeah, you can give a gap of one box. In the mark scheme they just give a gap of two. It's totally fine, it doesn't really matter, nobody cares. And yeah, 2610 go up to this box. On the other hand, we have 3010, which is like this, and it will go up to 2840. 1 2 3 4, where we have this, yeah. And then just connect the boxes. 2610 and 2710. Where is that? Over here. Okay, so that is it for our company A. So now we typically need to compare them. So who looks more spread out? They want a comparison. Oh no, they don't want a comparison. They want what would be a more appropriate measure than the median, or whether the mean would be more appropriate. So hear me out. Company B clearly has an outlier. What is an outlier? Look at this. One value is over here while all the others are over there. What does that mean? It's abnormally high. It's an anomaly or an outlier. So whenever you have outliers, the mean is actually overinflated, or it's like under the actual value or really high above the true value. Okay, either below or above the true value. So the mean is less appropriate. We need to explain why. So the mean is less appropriate than median because of extreme value for company B. Okay, that is what the mark scheme says at $3090. Or you could just say that no. Why? Because $3090 is an anomaly. Or you could just say that no, extreme value in company B. You just need to get the point across. Okay, that's it. Is that fine? Let's move on. How many questions do we have in total? I think 6 or 7. Oh, 6. Okay, so we have 3 questions left. A fair 5-sided spinner has sides labeled 1, 2, 3, 4, and 5. The spinner spun repeatedly until a 2 is obtained on the side on which the spinner lands. The random variable x denotes the number of spins required. So what is it? Is fair. So what is the probability? Let's draw the geometric distribution, right? So we can say that x is geometrically distributed where the probability of success is obtaining a 2, which is 1 by 5. So we need px is equal to 4, which is basically equal to p into q cube, because we need to fail twice to obtain the success on the fourth try. So 1 by 5 times 4 by 5 cube, or that is 0.2 times 0.8 cube, which gives us a value of 0.1024. Next, we need to find out px is less than 6. So I want to teach you a trick, guys. Always remember this. Where is it? Geometry distribution. This is the trick. So our targets are, these are the formulas that you need memorized. We need to target px is less than or equal to something, or px is greater than something. So in my current question, we have px is less than 6, which is not falling in any formula. But we can convert it to this. So what does px is less than 6 mean? It indicates 5, 4, 3, 2, 1. So can we not convert it to px is less than or equal to 5? That's the same thing, right? And then we can use this formula. Okay. So this can be written as px is less than or equal to 5, because this indicates that px is equal to either 1, 2, 3, 4, or 5. Okay. So we can now use the formula 1 minus q to the power 5, q to the power r, which is 1 minus 0.8 to the power 5. Let's do that. 1 minus 0.8 to the power 5, which is 0.67232 exactly. Or you could round it off to 0.672. Anything works. You could also do the alternate method where you could add all these up. That would also work. It's fine. Now, two fair five-sided spinners, sorry, each with sides labeled 1, 2, 3, or 5 are spun at the same time. If the numbers obtained are equal, the score is 0. Otherwise, the score is the higher number minus the lower number. Okay, so let's do this again. Let's go one more time. Okay, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So if the numbers are the same, the score is 0, 0, 0, 0, 0, 0. And otherwise, the score is the higher minus the lower. So 1, 2, 3, 4. 1, 2, 3, 4. Then we have 1, 2, 3, 1, 2, 1. Similarly, 1, 2, 3, 1, 2, 1. This is the table. Now, find the probability that the score is greater than 0, given that the score is not equal to 2. Okay, so what are the ones? I'm going to copy this, okay, because we might need this later again. So essentially, I need it to be greater than 0. So what does greater than 0 mean? 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 out of the 25 scenarios. So we need to learn how to write it first. That's our first step. So the probability is, firstly, remember that the condition is given at the end. Okay, the condition is that, what is the condition? How to figure it out? Given that, look for these words, given that the score is not equal to 2, this is the condition. So the condition is, you'll write the condition later, x cannot be equal to 2, but x has to be greater than 0. And always remember that the condition, okay, the condition will always go in the denominator. Okay, so the condition always goes in the denominator. So hear me out. In these cases, how many did I get? 20, right? 20 values where it is greater than 0. But honestly, we need to think of it in this way. We need another thought process. Always think of it in terms of the condition, okay? Because the condition will always get priority. The condition is the denominator, and you can only be a part of the denominator. So where is our score not 0? Sorry, where is our score not equal to 2? So basically all of them, right? Except these ones. 1, 2, 3, 4, 5, 6. Except these 6, all of them are valid. So if I circle them, this is fine, 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 this is also fine. Sorry. This is fine, this is fine, this is okay, this is okay, this is okay, this is okay. Here you go. It just can't be 2, yeah? So how many do we have in our condition where the score is not 2? It is 19 out of those 25 cases. Okay, the condition always goes in the numerator. How you find the condition is you look for given that. Now x has to meet this condition, okay, and also be greater than 0. So x has to meet this condition. That's why it has to be all the red circles as well as meet this condition. How? So we are going to cross out some of them. It has to be greater than 0. So this is excluded, this is excluded, this is also gone. Sorry, I missed one while I was circling. I missed these two while I was circling. So in total we have 19 circles. I only left out the 2's. And now when we find out the score, which is greater than 0 but also satisfies the condition of not being equal to 2, I'm getting rid of these. So how many did I get rid of? 5 out of these 19 cases. So how many do I have left? 14 out of the 25 cases. Okay, so my final answer is 14 by 19, or 0.737. So I want to clarify again, how do you do conditional probability? This type of sum is conditional probability. Find out the condition first by locating given that. It will be part of your denominator. So I located that. Scores that are not 2, except these 6 2's, all of them, all 19 of them are part of my denominator. Now from these 19, some of them, okay, from these 19 that are not equal to 2, some of them are also greater than 0. So from these 19 I excluded 1, 2, 3, 4, 5 zeros. So that's why I have 14 left, and that's the rest is history. Okay, you got it? Let's move on to the next one. The two spinners are spun at the same time repeatedly. Okay, now this is a geometric distribution. Whenever you see the word repeatedly, it is geometric. So now the geometric distribution is new. So we can say that y, okay, yeah, let's call it y, is geometrically distributed. And what is the probability of success? For 9 randomly chosen spins of the two spinners, find the probability that the score is greater than 2 on at least 3 occasions. Okay, so I might have misread the question. I thought it might be geometric, but actually, after reading the question more, since they've set a fixed number of trials, okay, so for a geometric sequence, you do not have a fixed number of trials. They're just going to ask you when was the first time. See, the spinner spun repeatedly until a 2 is obtained. The first time you receive a success. That is the criteria for a geometric sequence or geometric distribution where the number of trials might be infinite. You are just simply asked to find out the first time you get success. But in a binomial distribution, you will be given a fixed number of trials. For example, this question over here. So we can say that y is actually binomially distributed, and it's the formula is n comma p. So the number of trials is 9. I now have to find out the probability of success. So what is our success here? Find the probability that the score is greater than 2 on at least 3 occasions. Score is greater than 2. So what does greater than 2 mean? 2 is not included, 3 and 4 are. So 1, 2, 3, 4, 5, 6. Only these 6. Okay, only these 6. So basically my success is 6 out of 25 cases. This is my binomial distribution. Now the score has to be greater than 2 on at least 3 occasions. What does that mean? Py has to be greater than or equal to 3. 3 or more. Now this is quite impossible because that would entail py is equal to 3, 4, 5 and so on till 9. It's really long, right? 6, 7, 8, 9. So instead what we can do is we can just go for 1 minus py is equal to 0, 1, 2. So let's begin. 1 minus, it's going to be 9c0, then 6 by 25 to the power 0. What is 1 minus 6 by 25? 25 minus 6 is 19. 19 by 25. So 19 by 25 to the power 9, right? Then what else do we have? I'm just going to bring this to the left hand side. Plus 9c1, 6 by 25 to the power 1, 19 by 25 to the power 8, plus 9c2, 6 by 25 square by 19 by 25 to the power 6. So after proper working, let's do it. What is it going to be? 0 0.08459 plus 9c1 into 6 by 25 into 19 by 25 to the power 8, which is 0 0.2404. It's recommended that you take at least 4 significant figures in this type of math, plus 0 0.3037 for the last one. Overall, you're getting a final answer of 0 0.371. Okay, so yeah, it's just long working, otherwise it's fine. Wait, I'm just checking one more thing. Times 6 by 25 square. Sorry, I made a mistake over here. Should be 7. That is why it wasn't matching. So yeah, now it's 0 0.3037. I copied it from the mark scheme, but just checked later. Okay, so that is it. Hopefully you understood the working. So whenever you see for a fixed number of trials, you go for binomial distribution, find out the probability of success first, which I found out from the table that I drew. 6 out of 25 tries. Now I needed success on at least 3. What does that mean? 3 or greater, which is a very long process. So I went for the other route, 1 minus 0, 1, 2. And after the working, we arrive at our final answer. Okay, moving on to the last two questions. Let's do this. The lengths of western bluebirds are normally distributed with mean 16.5 cm and standard deviation 0.6. Okay, so we can say that x is normally distributed. Okay, and what is the mean? It is 16.5 and the standard deviation is 0.6 square. Okay, now how many of these 150 birds would have a length between these two? Alright, so why don't we just do this? Let's find out the probability that the length is between 15.4 and 16.8. So let's break it down first. You could break it down, like I prefer breaking it down first. So it's actually equal to p x is less than 16.8 minus p x is less than 15.4. This is the formula for the sums where you have x in between. Now we have to standardize it. So this is actually equal to pz is less than 16.8 minus 16.5 divided by the standard deviation minus pz is less than 15.4 minus 16.5 by 0.6, which gives us a value of pz is less than, this is 0.5 exactly, wow, minus pz is less than minus 1.833. So now you need to get rid of the minus sign. How do you do that? It's just 1 minus pz is less than the positive 1. What's the logic behind this? If you want to learn, minus 1.8 is somewhere here. So we are asked to find out this region. According to symmetry, this region over here is also the same. So if you actually subtract this purple region, which is less than plus 1.8 from 1, you actually get the pink region, which is equal to the blue one. I will plan to take a whole class on normal distribution later. So this is basically phi of 0.5 minus 1 plus minus minus plus phi of 1.833. So let's check the table. It is 0.6915 and 1.8 1.83. So 1.833 over here. Okay, so wait, I lost it. Wait up. We have 1.833. So this 2 should be added, right? This 2 should be added to 0.9664, and at the end, last position. So it's actually 0.9666369666. Okay, so let's get back to it. It is 0.6915 minus 1 plus 0.9666. 0.6915 minus 1 plus 0.9666, which is 0.6581. Now to finish the sum, we need to multiply it by 150 birds to find out the expectation. So the expected number is equal to 0.6581 times 150, which gives us an answer of 98.7, which is rounded off to, either 98 or 99 birds. It's up to you. Okay. Okay, so the lengths of eastern bluebirds are normally distributed with mean 18.4 and standard deviation sigma. So why don't we write y? Y is normally distributed with mean excuse me 18.4, and here we have sigma square. Now it is known that 72% of them have length greater than 17.1. So we can write that P y is greater than 17.1 is equal to 72% or 0.72. Now what? We have to standardize this. We can write 1 minus p y is less than 17.1 is equal to 0.72. So p y is less than 17.1 is equal to 0.28. Let's standardize it now. We can write pz is less than 17.1 minus 18.4 divided by sigma is equal to 0.28. This is the basic part. Now there are multiple ways that you could do this. Basically the value we are getting inside is negative. In the mark scheme they did not opt to do that. They kept it like this. Although I can teach you another trick. I'll show you that one soon. So basically if you have a value which is less than 0.5, you guys know this already, that the graph has 50% on this side. So since it's 28%, what does this indicate? This is 28%. Okay, so basically the thing is, my value inside here, this part over here, this is negative. Clearly it's negative. Now, what do I do when I have a negative value? Suppose I have p z is less than minus 1.833 like the previous one. What would I do? 1 minus p z is less than 1.833. This is what I do. Right? To convert any negative value to the positive one, we simply do 1 minus p z is less than the positive part. So this value over here, this thing over here, this is actually a negative value because it's less than 0.5. So to convert it to a positive value, what am I going to do? Basically 1 minus, right? 1 minus this is equal to the value on the right hand side that we have over here. But anyway, we can simplify this further. Check this. This is what we can do. They actually did something really strange in the mark scheme. So yeah, I'm converting the negative one to positive. So how do I do this? P z is less than, there is a minus sign here, the whole thing turns negative. 17.1 minus 18.4 divided by sigma is equal to 0.28. So after simplification, we end up with p z is less than minus 17.1 minus 18.4 divided by sigma is equal to 0.72. Now we can finally do it because it is greater than 0.5, so it is present in the table. So if we look for it in the table, I'm looking for 0.72, the closest number to 0.72, but it needs to be less than 0.72. So yeah, this is greater, but this is the one I'm looking for, and we just need to add 10 to turn it into 0.72. So I'm looking for 10. I got it over here. Okay. So yeah, what is the final answer? It is actually 0.5 0.583. 0.583 is our answer. Okay. So we can write this is equal to 0.583, 17.1 minus 18.4 divided by sigma. So 17.1 minus 18.4 divided by sigma is equal to minus 0.583. After simplification, what do we get? Let me take another step. 17.1 minus 18.4 is minus 1.3. Minus 1.3 by sigma minus 0.583. We can get rid of this. So 1.3 divided by 0.583. Sigma to three significant figures is 2.23. That's my final answer. I wanted to show you guys another technique. Basically, this is another root. You could write this first. 17.1 minus 18.4 is minus 1.3. You could write p z is less than minus 1.3 by sigma is equal to 0.28. Then you could just convert this to the positive one. You could write 1 minus p z is less than 1.3 by sigma is equal to 0.28, or p z is less than 1.3 divided by sigma is equal to 0.72. Then we could simply input 0.583 over here. 0.583 is equal to 1.3 by sigma, and therefore sigma is equal to 0.583, sorry, 2.23, right? So isn't this system better? In the mark scheme they did this method, but honestly my method works as well because I used it in my exam when I gave the A levels paper, and yeah, I got full marks in this component. So yeah, it's supposed to work. So if you can convert it to a native value, why not do that? And afterwards you can just find out the answer directly. Or this method works as well. In the mark scheme they don't show plenty of steps. They actually skip this step over here. They write that one directly, right? They actually skip a lot of steps. They directly go here. They skipped all of this and they directly go there. So that's kind of crazy. So yeah, you should be showing all the steps carefully, and then it should be fine. So So yeah, let's move on to the next part. 2.23. Okay, we need an approximation. A random sample of 120 eastern bluebirds is chosen. So x is binomially distributed because we have 120 birds, right? And what is n? 120. And what is the probability? Use an approximation to find the probability that fewer than 80 of these 120 bluebirds have length greater than 17.1. Okay, so length greater than 17.1. Are we talking about eastern or western? Eastern bluebirds, this one. So it is known that 72% of eastern bluebirds have length greater than 17.1. So fewer than 80 have length greater than 17.1. So what is the probability of success? It is also 72%, which is 0.72 NP. Now we know that the formula for mean is NP, which is 120 times 0.72, 86.4. And we also know that variance is equal to NPQ, which is 86.4 times 0.28, right? Which is 24.192. So we can approximate it in the next part. We can write that y is normally distributed. I'm converting the binomial distribution to a normal one. When do I do this? When we see this word approximation. Because fewer than 80, to do it like we did over here in this previous sum, it would take ages. Like we had to do 40 or 80 at least, right? So that's impossible. So we just approximate to a normal distribution where, the mean is 86.4 and the standard deviation or variance is 24.192, like this. Okay, now let's get to the main part. Fewer than 80. So what does that mean? P x is fewer than 80. See how I used 8 x, I mean not y, because that's the main distribution. So what does fewer than 80 mean? Suppose if this is 80, this is 81, and this is 79. Fewer 80 means that 80 is not included. It refers to these areas, right? 80 is not included, and it is in a region that is in between 80 and 79. In between 80 and 79. So what is that point exactly? 79.5, right? So you have to approximate it to py is less than 79.5. So this thing is called the correction factor, where we convert a binomial distribution to a normal one. You have to ensure that you apply the correction factor of 0.5. So if it was at most 80, it would have been x is less than or equal to 80, and at that point it should have been py is less than. So yeah, you have to apply this factor. If it was less than or equal to 80, at most 80, it would have been, when you convert it, 80.5. Why? Because 80 would have been included, so it would start from here. So there are 4 variations in total. So now what do we do? This can be written as pz is less than 79.5 minus the mean 86.4 divided by the standard deviation, which is root over 24.192. Okay, so 79.5 minus 86.4 divided by root over 24.192. So we end up with pz is less than minus 1.403. Always remember 3 decimal places or else it won't match. Okay, now this can be written as 1 minus pz is less than 1.403. Let's just go to the table. 1.403, so 1.40, 0.91923, which is this one, 4. We have to add 4 here, so 0.9196, 0.9196. 1 minus 0.9196, which gives us 0.0804. That's my final answer. Okay, hope that helped. So this is a typical approximation sum. You will have one of these, at least one of these. Usually one, not more than one in your paper. Okay. Last one then. Permutation combination. In a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. A team of 7 people is selected from 25 people to take part in the competition. Find the number of different ways in which the team of 7 can be selected if it consists of exactly one swimmer, at least 4 cyclists, and at most 2 runners. Okay. So swimmer, cyclist, runner. We need to pick 7 people. And one swimmer is fixed. We can have at least 4 cyclists and at most 2 runners. So this is one combination, 2 4 1, which is 7. At most 2 runners. So what can we have? One swimmer, one runner, then 5 cyclists, and what's the last one? One swimmer. Like they didn't say that you need to. Each person competes in one. They didn't say that you need to pick one runner at least. Like we could even have 0 runners, right? So that in that case you'd have 6 cyclists, because we can have at most 2 runners, but the lower end was not mentioned. So what is this? From the 6 people, 6C1. From 6 swimmers, I'm taking 1 times 8C4 times 11C2. It's a hard day for runners, honestly. 6C1 into 8C5 times 11C1 plus 6C1 into 8C6. Okay, so 6C1 into 8C4 into 11C2 plus just 23,100. 6C1 into 8C5 into 11C1 3696, and plus 6C1 into 8C6 168, which gives us 26964. That is our answer. Okay. Last few parts. For another competition, a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. The team member stands at a line for a photograph. How many different arrangements are there? If the swimmers stand together, the cyclists stand together, and the runners stand together. Okay. So 2 swimmers together, 3 cyclists together, and 4 runners together. So how many units are there in total? 3 units in total. So for them, we have 3 factorial for 3 units. And for each of them, we have 2 swimmers, so 2 factorial, 3 cyclists. They can interchange between them 3 factorial times 4 factorial. See if it makes sense. So 2 factorial into 3 factorial into 4 factorial into 3 factorial, which is 1728. That's the basic gist. For 3 units, 3 factorial, and for each interchanging within each unit, we have 2, 3, and 4 factorial. Okay, that is your answer. Next one, how many different arrangements are there of 9 people if none of the cyclists stand next to each other? Okay, of these same 9 people, but the cyclists cannot stand next to each other. Okay, so we are going to put in the blanks for the swimmers and runners. 1, 2, 3, 4, 5, 6. So like swimmer, swimmer, runner, 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 runner. For them, they can interchange their positions and they're all unique. So it's just going to be 6 factorial for them. Now for the cyclists, they cannot stand next to each other. So we have to go for the arrow method. 1, 2, 3, 4, 5, 6, 7. Always remember one more arrow than the number of blanks. So I have 7 arrows and I am going to put in 3 cyclists there, which is going to be 7p3. P because they're all unique. Okay, so 6 factorial into 7p3, that is giving me an answer of 151200. I'll just check the mark scheme. Yep, that is 100% fine. See if you guys get it. This is a really common question that you have to answer. You need to know how to answer. And yeah, that's about it for the paper. So I hope you like the content. Please do comment below requests for paper solving. If you did like the video, please consider subscribing to the channel and also supporting me on Patreon. Quick shout out to my top tier patrons for the month. We have Dewa, Luna, and Sean supporting me for this month. If you want to be presented on the screen as well, please do consider supporting me. You also get access to all my solved question papers, as well as priority for questions paper solving requests, as well as video meetings with me. Also, I am going to link the paper for May-June 2023 paper 5.1 and May-June 2023 paper 5.3 when I solve those. The playlist for my S1 videos over here. And yeah, remember to hit the subscribe button. See you guys.